Hello and welcome to a video about what oil and oil filter to use in your Toyota, and also what kind of oil change interval should you be looking at. So what I want to talk about is oil viscosity, oil specification, oil change interval, and then in the second part of the video to look at aftermarket and original Toyota filters for your Toyota car. The reason I'm making this video is there's an awful lot of stuff on the internet, particularly on YouTube, people talking, arguing about using thinner oils. Should I use a 0W20, a 5W30? There's a fair amount of suspicion about the manufacturer recommendations, and also there's often the comment that in different countries different oil viscosities and change intervals are specified for the same Toyota engine. So what I want to do is really sort of get at the truth behind this, and then in the second part of the video we'll also have a look at Toyota oil filters and look at aftermarket oil filters. And again, there's a lot of videos, people cutting open filters and discussing the various different brands. So I just want to try and cut through some of that a little bit. Now, back in the 1970s, we used to use multigrade oils, the first multigrade oils in the UK. Certainly 20W50 was very popular. So we've got the two numbers, the 20W and the 50. The W stands for winter. So 20W50 means in the winter, the oil, in other words, in cold weather, the oil has a cold viscosity of 20, and when the engine's hot and at operating temperature, it has a viscosity of 50. And you don't really need to worry too much about what those numbers mean, but they're actually measured on a different scale. So the 20 and the 50 are measured on a different scale. So 20 refers to the cold oil viscosity, which is obviously important in the winter when you start in the car. We've got temperatures at 0 or below 0 Celsius, and then 50 is the hot oil viscosity. And as time went on and engines were developed with smaller clearances, the vehicle manufacturers started to specify thinner oils. So we went to 10W40s, 5W40s, so on. In the last, I suppose in about the last 10 years in particular, there's been a drive to use very thin oils. And in fact, some of the latest Toyotas use a 0W8. And the drive towards these thinner oils is really down to the tightening of emissions and fuel economy regulations. So manufacturers are under huge pressure to improve the fuel efficiency of the vehicle, and of course along with that, if you improve the fuel efficiency, the emissions also improve. You get less in the way of CO2 emissions. And there are organisations around the world. In the USA there's the CAFE, Corporate Average Fuel Economy, sometimes known as CAFE or CAFE, which I believe is administered by the EPA over there, and they are pushing manufacturers to produce vehicles with better fuel economy. There are minimum fuel economy requirements, and manufacturers suffer additional taxes and even fines and so forth if their vehicles can't match these standards. In a lot of the rest of the world there's the WLTP, which is the worldwide harmonised light vehicle test procedure, and that is another standardised measure of fuel economy and CO2 emissions in particular. And obviously manufacturers are very keen to display good figures in these tests, because that often translates to, for example, lower taxes, running taxes, lower sales taxes, depending on which country you're in. So manufacturers are under enormous pressure to improve fuel economy and reduce emissions through all these different standards. Now, part of that can be achieved by making the vehicle lighter, improving the design of the engine to improve combustion efficiency. We can use things like pseudo-Atkinson cycle, which is used on some of the Toyota engines. But one way of getting a few percentage point improvement in fuel economy and emission reduction is to use a thinner oil, because when the engine's running, when it's operating, obviously it has to circulate oil around the engine, and that oil sits between the moving parts of the engine, and it creates drag. A certain amount of energy is therefore needed from the fuel to overcome those internal losses associated with moving the oil around. Okay, and that's generally known as windage. Okay, so a reduction in oil windage generally will give you a very small improvement in fuel economy, percentage point or two, and a consequent reduction in emissions. So what the manufacturers want to do is reduce the oil viscosity and reduce that windage. So the task of the lubrication engineers in Toyota is to come up with an oil specification that allows the engine to achieve a reasonable life. Okay, we don't want the thing to wear out, certainly not within the warranty period, but also have minimal windage. So there's a lot of pressure toward thinner oils, and some of the latest Toyotas run a 0W8, which is a very thin oil. Now, part of that can be achieved, part of the durability and endurance can be achieved by improving the additive pack that goes into the oil. So if we look at any engine oil, if we buy engine oil in the UK, there's literally a handful of suppliers of the base oil. So an oil retailing company, an oil marketing company will buy in base oil from one of these handfuls of suppliers in Europe, and similarly there's just a handful of suppliers in the US, and they will blend that with an additive pack. And again, around the world is just a handful of suppliers of these additive packs. And Lubrizol, there's Lubrizol Infinite, I think there's one called Afton. There's literally, I think there's 4 or 5 around the world. So pretty much all of the oil you buy will simply consist of a base oil bought in from one supplier and an additive pack bought in from one of these additive manufacturers, and they'll be blended together, and the oil will then be marketed and retailed and so forth. And around somewhere in the region of 10 to 20% of the oil will be the additive pack. And the additive pack consists of anti-wear and friction reducing compounds. ZDP, which is a zinc compound, is probably one of the best known, and that I think Lubrizol developed that back in the 1940s, and that basically coats the bearing surface with a film of zinc. We've got molybdenum additives, boron additives, then we've got anti-foaming agents, we've got dispersants to stop soot particles sticking together and blocking the oil filter and so forth. We've got detergents which mitigate against varnishing of components inside the engine. Yeah, anti-foaming additives and antioxidation package. So the additive pack is really there to boost the performance of the oil, and it's a very finely balanced set of compounds. Okay, and that's one reason why you shouldn't pour aftermarket additives into the engine oil, because you'll upset that balance. And the performance of the oil can then be, the overall performance of the oil can then be assessed in terms of its performance in protecting the engine. And I'm making this video in July 2025, and at the moment probably the the best known performance specification is from the API, the American Petroleum Institute, and at the moment we're on SP. Okay, so I think years ago they started on SA, then it went SB, SC, and now we've got as far as SP. In Europe we have some slightly different standards, the ACEA for the European constructors, and in particular for at the moment for Japanese vehicles there's something called the ILSAC standard. So the ILSAC is the International Lubricants Standardization and Approvals Committee, ILSAC. And the ILSAC really, it consists of representatives from Japanese manufacturers and American manufacturers. So it only applies to Asian and American cars. And at the moment, July 2025, we're on ILSAC 6. And ILSAC 6 takes in the API SP specification and adds to it a requirement for what's called resource conserving. In other words, good fuel economy. So at the moment, if you've got a Toyota, right now the requirement is for an ILSAC 6 engine oil. Okay, so I've got one here. This is Liqui Moly's, they call it Special Tech AA0W20 Asia and America. So this meets API SP, and it also meets ILSAC GF6 standard. Okay. Another one here in the UK, we've got Miller's Oils, which I think is a very good quality oil. This is their 5W30, and again this meets API SP, SPRC. The RC stands for resource conserving, which means it promotes good fuel economy, and it meets the GM standard Dexus 1, and we also see that it meets ILSAC's GF6. So again we could use this. Now the point is that pretty much every motor oil that you can buy that's marketed out there is this blend of a base oil from a base oil supplier and an additive pack from an additive pack manufacturer like Lubrizol. They're blended together and then packaged and marketed. And the simple fact is, if the oil meets the spec, it meets the spec. It's as simple as that. So if your car requires an ILSAC 6 spec oil, really it doesn't matter which oil brand you buy. If it meets the spec, it should be fine for the vehicle. So you can choose to buy on price, or you can maybe you trust one brand more than another. Maybe you think the quality control is better or whatever, and you buy that and possibly pay a premium. So personally, I would buy pretty well any known brand that meets the spec. If it's a complete off brand I've never heard of, sold on eBay, then maybe I'd be a little bit worried about buying that. But generally, if it meets the specification, then go out and buy it. And the reason I bought Liqui Moly is because they're a German company. I think the quality control is pretty good, and also the price is very reasonable. It's not, I'm able to buy this at a fairly modest price, not at a premium price. So yeah, you buy the oil specification to suit your car. Now the other thing that causes a lot of contention in internet forums and so forth is the viscosity of the oil. So most Toyotas at the moment are asking for a 0W20, a 0W16, or some of the very latest ones, a 0W8. And you know, some owners get concerned about this and feel that the oil's too thin, and they want to put a thicker oil like a 5W30. And the fact is that, leaving aside the latest engines that require 0W8, it actually doesn't really matter. And I'll explain the difference between oil requirements and oil recommendations, and why, if you wish, you can use a 5W30. Now, when the manufacturers test the vehicles or submit the vehicles for testing to these fuel economy and emission standards, obviously they have to supply the vehicle in a particular configuration. So it's supplied with a particular coolant, a particular transmission oil, a particular engine oil, and so forth. And there is a requirement that that is the configuration they sell the car with and recommend servicing to. So the servicing recommendation must be to that standard. So for example, if Toyota supply a car for testing to the WLTP standard and it has a 0W20 engine oil in it, they can't then sell cars with a 5W30 and recommend their dealers to put a 5W30 in at service. That would be kind of gaming the system. That would be testing the car in a different configuration to which the general public are going to use the car, buy the car. So that's why when you look in the owner's manual, you'll see that it recommends a particular oil specification, usually 0W16 or 0W20, but you'll also see that they also permit use of thicker oils. So generally they will recommend the thinnest oil they can get away with because that was the oil used for the fuel economy and emissions tests. But in actual fact, you can, if you wish, use a thicker oil. And there's usually a little chart or a table in the owner's manual that shows the range of oils that can be used. And I will drop that into the video right now. So basically that's the situation. And in fact, if we're looking at, for example, the difference between 0W20 and a 5W30, it doesn't really matter. There's not very much difference. And I'll explain why. The viscosity of oil is what we call a kinematic viscosity, which is the viscosity that the oil presents to moving parts within the engine, is measured using a unit called a stoke. And this goes back many years, many decades. Unfortunately, the stoke is rather a big unit. It's rather a big and clumsy unit. So in general, with modern engine oils, we measure viscosity using the centistoke, 1/100th of a stoke. Now the thing about engine oils is that the viscosity drops very sharply with temperature. So to give you an idea, let me quote some figures. If we've got a 5W30 oil, at 0 degrees Celsius at freezing point, the viscosity of that oil is somewhere around 600 to 700 centistokes. At 100 degrees, by the time the engine's up to temperature, the viscosity is probably around 10 to 12 centistokes. So we are looking at a 70-fold reduction in viscosity from 0 degrees C to 100 degrees C. So that is a huge change in viscosity. Okay? And similarly, a 0W20 is going to go from something like 500 centistokes at 0 degrees Celsius down to 7, 8, 9 centistokes at 100 degrees. So again, that's around a 50-fold reduction in viscosity. So as the engine warms up, the viscosity drops very sharply. And manufacturers put various additives into the oil so that it doesn't drop too much, so-called viscosity modifiers or viscosity improvers or whatever. Okay. The other critical thing is at the operating temperature. So most engines are going to operate somewhere around 90 degrees C, maybe the oil's 90 to 100 degrees C, that kind of temperature. The difference between a 5W30 and a 0W20 is only around 20% in viscosity at 100 degrees C. So at 100 degrees C, the 0W20 is only around about in the region of 20% thinner than the 5W30. And that doesn't really make very much difference. It's probably reflective of sort of 1% on fuel economy. It's a tiny difference in fuel economy and a tiny improvement in emissions. But the manufacturers are trying to grab at every opportunity they can to reduce fuel consumption and improve emission performance. Okay, so that's why they recommend that. But in terms of operation at normal temperature, the typical operating temperature, the difference in viscosity really is pretty small. There is, however, a bigger difference at low temperature, because at low temperature, the 5W30 is going to have a viscosity of somewhere between 600 and 700 centistokes, and the 0W, the 0 there is important, will be a little bit thinner. That's going to be around a 500 centistoke viscosity. So at the lower temperature, around 0 or sub-zero, using the 0W rated oil will be an advantage compared to, say, the 5W. And the reason is that obviously when you crank the engine, the oil is going to flow more easily, there's going to be less load on the starter motor, and the oil is going to flow around the engine more easily. So if you're in a cold climate, if you're in Scandinavia, Canada or wherever, then there's certainly an advantage in looking for an oil that has a 0W rating, because it will give you that improvement in cold start. In a temperate climate like the UK and Central and Southern Europe, the difference is marginal. So the upshot of this is, for a normal internal combustion engine Toyota, for a non-hybrid, whether you use a 0W20 or a 5W30 is, it's not particularly critical. And as I say, if you look at the chart in the owner's manual, you'll see that Toyota are quite happy for you to use a range of different oils. And indeed, if you're running the car very hard, so if you're tracking a car, if you've got something like a Toyota GT86 and you are tracking it where the engine's going to be under more load and there's probably higher temperatures, then there will be an advantage in going to a thicker oil, okay? A 5W30, even a 5W40, to give you that better oil film, the stronger oil film at the higher temperatures and higher loads, okay? But most Toyota internal combustion engines are operating at modest load. If we're into turbocharged stuff, then that's a whole different ball game, and you need to do some research on the best oil to use with a turbo, because again, you may need to go to a heavier viscosity. Now there is a particular recommendation here for hybrids, okay, for Toyota hybrids. So Toyota hybrids are interesting in that, depending on how you drive the car, the internal combustion engine may not be running an awful lot, okay? So if we look at something like a Toyota Prius 1.8 litre engine, it has an electric cooling pump, and the computer control system tries to get the car to run at 90 degrees C. That's its target temperature. So if I drive out onto the motorway and I'm cruising, the internal combustion engine's operating, the temperature gauge will climb fairly swiftly, and then it should remain pretty much rock solid at about 90 degrees C. And the oil's hot and it's fairly thin, and we're getting good fuel economy. However, if we use the hybrid in urban and suburban driving, for a lot of the time, the internal combustion engine may not be running. When we're stopped at traffic lights, the internal combustion engine switches off, and obviously we're using regenerative braking a lot. So, you know, we may find that the internal combustion engine is only running for half the time. So for a lot of the time, the internal combustion engine it's not hot. It's running, if you like, in a warm-up phase. And so what you get is sort of this seesawing of oil temperature. As the engine runs a bit, the oil warms up, and then the engine shuts off, it cools down, and we've got this sort of sawtooth pattern to the oil temperature, and that brings a certain problems with it, because, you know, with oil it's a bit like Goldilocks and the three bears. Yeah, if the oil is too cool, that's not good, because the contaminants, you know, we get fuel contamination into the oil, we get blow-by gases into the oil. Those contaminants are never boiled off. If the oil doesn't get very hot, those contaminants tend to sit there. On the other hand, if the oil gets too hot, then we get, you know, problems like oxidation and so forth, and breakdown. So we don't want the oil too hot. We don't want it too cool. We want it at, you know, just right, which is, you know, 90 to 100 degrees C, something like that, which is hot enough to boil off the contaminants, but not to degrade the oil. So with the hybrid, then we do have this this seesawing of temperature when they're used in urban and suburban driving. And we know that, for example, engine wear, decades of research have shown that engine wear is highest at low oil temperatures, and it tends to drop, so that by the time you get to about 70 degrees C, the engine wear is much reduced. So really we want the oil to be above about 70 degrees C to minimise engine wear. Temperatures below 70 degrees C, the engine wear increases quite noticeably. So we've got that aspect, that hybrids in some ways are actually pretty hard on their engine oil. The second thing, of course, is with that lower temperature, the oil is thicker. So the 0W20, it's no longer at 100 degrees, it's got a viscosity of somewhere around, I don't know, 8-9 centistokes. If we go down to, say, an average temperature of 70 degrees C, the viscosity might be considerably higher than that. You know, it might be, I don't know, 30 centistokes. So the thinner oil using the 0W20 gives us an advantage in the hybrid, because the engine's running a little bit cooler. And if we're using something like a 5W30, there's actually going to be quite a big difference in viscosity at 70 degrees C. Of course, a lot of this depends on how you use the vehicle. If you've got a Toyota hybrid, and you've got a daily commute that involves a spell on the motorway and then a bit of urban driving, that's fantastic, because you're getting the engine up to temperature, you're getting the oil nice and hot. But if it's mainly short journeys in traffic, then you're going to contaminate the oil much more quickly, because the oil's just not getting very hot. And that brings us on to the oil change interval. So again, manufacturers, basically, they get brownie points from the various governmental environmental agencies around the world. They get brownie points for reducing the resource usage, which includes engine oil. So the manufacturers are very keen to reduce service intervals. And obviously that's also an aspect of sales. If you're selling the car to a customer, it's more attractive if the customer only has to visit the workshop once a year for a service rather than once every 6 months. So certainly in the UK and most of Europe, there's been a push to longer service intervals. And oil formulations are taking account of that. So, you know, we've got higher amounts of detergents and dispersants and so forth to attempt to keep the contaminants floating around and the oil not settling out into the oil passages and so forth. But it's not ideal. And my recommendation, certainly if you've got a hybrid, is a sort of 6-month, 6,000 mile oil change interval, because in the hybrid the oil is getting contaminated. For non-hybrid internal combustion engines, then yeah, you probably can push it out to longer oil change intervals, but a lot depends on how you're using the car. If you've got a car, you know, if you make a daily visit to the local supermarket, which is just a few miles away, the engine never really gets hot. It's probably worth, even though you're doing a low mileage, it is probably worth going to a 6-month, 6,000 mile max oil change interval. If you've got a daily commute that involves a little bit of higher speed driving and every day the engine's getting good and hot, then paradoxically, although you're covering more miles and you're covering them at a higher speed, the engine oil is probably going to be in a better condition. Okay, so for those of you that are running hybrids and doing a lot of short journeys, you know, you're getting contamination of the oil, you're getting dilution, the viscosity of the oil will slump because of the dilution, and you know, we're getting acidic and corrosive compounds formed in the oil which attack oil seals and so forth. So my advice is, with a hybrid, yeah, go for the thinner oil, go for the 0W20 or 0W16, and go for more frequent oil change intervals. Okay, so that's the advice from me anyway. So the next thing we'll look at, we'll go on and we'll look at Toyota oil filters. Okay, let's talk about oil filters for your Toyota. Toyota original equipment filters, and we can look at aftermarket filters. And you know, this is one of the areas where there's a lot of YouTube videos, and the Americans in particular, they seem really keen on playing around with oil filters. There's quite a few channels where they test them, they cut them open, they stretch out the filter material and all the rest of it. Let's just look at what kind of filter we can put on our Toyota and the different options that are available. Now, Toyota have always been fairly sensible with oil filters. There are some manufacturers out there who pretty much every engine they introduce has a different size and shape of oil filter. But for the most part, for their small and medium size petrol engines, Toyota have essentially stuck with the same format of oil filter. I mean, these were going back, I don't know, 40 years, back to the late 1970s, I think, when they came up with this is what we call a spin-on oil filter. The element is contained in this metal casing. There's a threaded boss there that screws onto the engine block. And these are 75 millimeters high, 68 millimeters in diameter, and they have 14 flutes on here. So there's a fluted end. We can buy a socket to loosen or tighten the filter. So 14 flutes on a 64.5 millimeter diameter across there. And these have been in production for about the last 40, maybe more than 40 years, and they've used them on everything from the Igo, the Yaris, Corolla, certain models of the Camry. Obviously the big engines, the V8s and so forth, and the diesels use different filters. And there are some Toyota vehicles that use non-Toyota engines. So there's the Subaru engine in the GT86, there's BMW engines pop up in one or two of their other models that obviously use Subaru and BMW filters. So this metal spin-on filter, 75 millimeters high, has been pretty much of a standard across a lot of Toyota vehicles. Now, in some ways these are a little bit wasteful, because when you change the oil and you change the filter, obviously you're going to throw this away. So there'll be a certain amount of oil held inside this thing, which is a potential contamination if this ends up in landfill. But you've also got some valves in here. You've got an anti-drain back valve in there, and there's actually a bypass valve in there as well. So this all gets thrown away. And so what Toyota have done in recent years is they've actually just sought to reduce the size of this filter a little bit. So if you buy a filter, if you bought a filter recently, you might find it's only 70 millimeters high rather than 75. The diameter remains the same, so just a small change. Now, a few years ago, in an effort to reduce the problem associated with the disposal of these metal spin-on filters, Toyota introduced an element type filter. So what they did is, if you've got a car, I think probably from something like, started around 2009 and through to about 2018, they introduced a slightly different filter system where we had a paper element filter. So this is actually a paper element oil filter, and we have this reusable filter cap. Okay, and so what we do is the element pushes onto that support tube, and that then screws into a housing on the engine block. Okay, and so when we change the oil, we just unscrew this cap, and we only need to change the paper element. And there's an anti-drain back valve within the housing on the block, and we've got a bypass assembly in this cap. Unfortunately, this didn't go too well. The main reason was that technicians tended to over tighten these caps, and the cap would either break on tightening, or more likely when another technician tried to remove the cap for the next oil change, the thing was pretty much welded on there and the cap would crack or break. And obviously that's a major issue during an oil change, because if you crack or break this, the vehicle is immobile until you get a replacement part. So it seems like they're phasing out this paper element. So I think from about 2000, certainly on cars like the Prius Gen 4, I think, which was 2016 to 2018, had these, and then they went back to these so-called spin-on type metal cans, because it was just a lot less hassle for them. Okay, so so just be aware if you've got one of these, the torque is actually, the tightening torque's actually marked on this cover, and it's 25 Newton meters. So you don't over tighten these, you just put a new O-ring on there and you just nip the thing up gently. You know, it's not going to unwind itself particularly easy. 25 Newton meters is quite a modest torque. So there is that kind of filter. Now the standard Toyota spin-on filter will have a part number, if you can read that, 90915. So that part of the first 5 digits there of the part number, 90915, indicates that it's one of these metal spin-on type filters. The second 5 characters then indicate the variation. Okay, so there are variations depending on the exact height of the filter, whether it's 70 or 75 millimeters, and also where it's sourced from, and also whether it's a so-called value part or not, and I'll explain what I mean by that. So this particular filter here, this is 90915 10009. I actually got this from a Toyota dealer in Osaka in Japan. It cost about £7. This is the actual factory fit oil filter. So this is a factory fit oil filter. It's 70 millimeters high, it's made in Japan, and it fits you know, recent model, well, a lot of recent models, Prius, Corolla and so forth. Okay, Now, if you go into a Toyota dealer in the UK or Europe and the US, they're unlikely to have this oil filter in stock. Okay, they'll have a 90915, but it won't be 10009. These are not usually supplied for dealers to fit during a service. What you're much more likely to get is a filter with a part number that looks like this. Okay, so again 90915, but this time YZZE1. Okay, YZZ indicates a Toyota market value part. Okay, so what these are is these are filters that are produced to a slightly lower cost. Usually they're not produced in Japan. They'll be manufactured in China or Thailand or Indonesia, possibly in Europe, maybe some are made in the US as well. So when you see YZZ in a Toyota part number, that means it's one of these MVP, market value part. And the idea is that it can sell at a slightly lower cost, it can retain some profit for the dealership, but it's still, it's still a Toyota part. The second two characters, this says E1, that actually indicates the variation. You'll see lots of different characters there depending upon where the filter is made and whether it's a 70 or a 75. Now the honest truth is, if you've got a well-serviced Toyota, if you're changing the oil frequently using the correct oil, and if it's a hybrid, if you change it every 6 months, 6,000 miles to keep the oil in good shape, the filter is not actually going to be doing very much. Okay, the filter is there to, a typical oil filter is there to filter out particles above about 25 microns. You can't see anything below about 40 microns, so it's filtering out very, very tiny particles. But in a well-serviced engine that's had regular oil changes, it's not got something wrong with it, there isn't a component wearing out and shedding debris, the oil filter is actually, it's not going to be doing a great deal. It's not going to get heavily contaminated. And, people worry about whether they fit a 70 or a 75 millimeter high filter because they think the 75's got a little bit more filter material. Really, you don't need to worry about that. Okay, the filter material should be pretty clean, and if you look at some of the videos that are on YouTube and you cut open one of these filters after 6,000 miles, it's pretty clean in there. So don't get too obsessive about thinking your filter's going to block up or something. Okay. So what we've got 70 or 75 millimeter oil filters, and whether you get the factory original, the 10009, or you get something like a YZZ, this is a YZZN2, so this is the MVP, the market value part equivalent of the 90915 10009. This is the equivalent. This particular one is made in Thailand. Nothing wrong with that. Toyota have been making oil filters in Thailand since the 1970s. Okay, they know what they're doing. Actually, the filter itself is manufactured by Denso. If you look on there, it says Denso. Denso are part of the Toyota conglomerate. So Denso is effectively a parts supplier element of the Toyota Corporation. Okay. In terms of what's in the oil filter, let's have a look. Let's look inside an oil filter. So what I've got here is I've got a 75mm Toyota oil filter that that I've cut apart. Okay, so I've opened this up, and what we've got here is the boss that screws onto the engine. So there's a threaded tube that this screws onto. We've got the rubber seal there. Toyota usually put a little plastic sort of cellophane cover over with a bit of silicone grease underneath to keep the rubber in good shape. And on the back there, you'll see there is this sort of rubber ring which covers the inlet holes. So the oil flows into the filter through these holes. It flows around the filter element. So here is the filter element. So oil will flow in through those holes, past that flat valve and through the filter element, and it'll exit through that hole in the middle and go off into the various oil passages within the engine. Okay. This little flat valve on the back of those holes, those inlet holes, this little rubber flap, that's just an anti-drain back valve. So the idea is if the filter is mounted kind of in that orientation vertically or horizontally, then the idea of that flat valve is it's a one-way valve that stops the filter draining out when the engine's off. And when you start the car up again, you've already got a filter full of oil and you get circulation a little bit quicker. Okay, so that's the anti-drain back valve. We've then got the filter element which sits on there. So oil flows in through the pleats in this filter material and into the middle of the filter here and exit out of this hole. At the back here, you'll see this little kind of poppet valve arrangement here. So there's a little valve there, and what happens is if this filter becomes clogged, which is very unlikely, but if it does become clogged, then there will be a pressure differential developing between the outside material here and this inner tube. Yeah, so there'll be if the filter's clogged, there'll be a pressure difference. If that pressure difference exceeds about a half a bar, that's about 7 psi, that's enough for the oil to force open this little valve, and oil will circulate through the valve and off into the engine. So the oil doesn't get filtered, but it can still circulate around the engine. So the theory there, it's better that the engine receives dirty oil than no oil at all. So that is the bypass valve. Okay. Now there's a common misconception this bypass valve determines the oil pressure in the engine. It doesn't. The oil pressure in the engine is set by an oil pressure relief valve in the oil pump in the engine block. So when the pump runs above a certain RPM, the oil pressure kind of hits a maximum, and then that relief valve opens and that maintains the oil pressure at whatever it should be for the particular engine. So this bypass valve only opens in a condition where there's a pressure difference across the filter element. Now it can actually open at high speed, a very hot high speed operation, because when the oil's very hot, it gets very thin, it flows out of here very quickly into the engine, and it flows around the engine components very easily. And so there's not very much back pressure here. And that can lead to enough pressure difference across the filter for this bypass relief valve to open. So it can actually open a bit when the oil's very hot, very thin, and the flow rate is high. But again, that's not something you're going to need to worry about. So yeah, in a nutshell, that's the Toyota oil filter. Now, you don't have to fit Toyota. There are obviously there's plenty of other brands that are out there. So this is a Bosch filter, and I've taken measurements and compared these with the Toyota original filter. Perfectly acceptable. Bosch are a very good company, no hesitation at all in using those. And a filter I like is the Hengst. Hengst are a German company. Most of their oil filters seem to be made in Poland, and they do make an oil filter suitable for these Toyotas. It's the H97W07. And again, these are a well-made filter. So I would have no hesitation in using a well-known filter brand. So we've got brands like Man, we've got Hengst, we've got Bosch. There's a few others. Okay. So if your car is well serviced, if you change the oil reasonably frequently, so long as you use a decent known brand, I wouldn't be overly concerned. I wouldn't sort of lose any sleep over it. And whether it's a 70 or a 75mm high filter, again, don't worry too much. You've in a reasonably well serviced car where the engine's in decent shape, the filter is not going to get clogged up. Okay. Now the next thing I'm going to go on to is I'm going to talk to you a little bit about fake Toyota filters, and this is quite interesting. So let's look at a fake Toyota oil filter. Okay, so let's briefly talk about fake Toyota filters, oil filters. So I get to travel quite a bit, and a few weeks ago I was in China, and I saw for sale in a motor parts store hundreds of different filters, Toyota, Honda, Mitsubishi, so forth. And this caught my eye, 90915 YZZ-E1. This is the common type of oil filter, fits a lot of Toyota petrol engine vehicles, small to medium size engines. And what particularly interested me was the fact that this was for sale for the equivalent of about $1 US. Okay, that's about 70 pence or about €1 roughly. Okay, which seemed pretty amazing. So with the aid of Google Translate, I spoke to the guy in the store and I said, "Are these fake or original?" And he said, "Fake, of course." Okay. And I could have bought a box of them. They had boxes of 10, a carton labeled Toyota Lexus genuine parts. So I bought a couple of these. I bought 2 of them, and I studied them. And what I've got here is another filter. I know this is a genuine one. This was purchased from a Toyota dealer in Osaka, in Japan. Cost about £7. This is the factory fit original Toyota oil filter, and I compared them, and the fake is astonishingly good. If you didn't have another genuine Toyota filter to compare it with, you wouldn't be able to spot it was a fake. The attention to detail is absolutely amazing. If we look at the box, look at the boxes, we compare the boxes, the way the boxes are cut and folded, the slight angle on the cardboard of the fold underneath, the printing on the base of the box, everything is pretty much perfect. Okay. On the cellophane that covers the filter inlet there, it has a serrated edge, and the fake one has the same serrated edge as the original. So amazing attention to detail, date codes and everything printed the same. So are we able to tell the difference? Well, the only way I was able to really pick fault with the fake one is that the printing on the filter, there is a slight misalignment. I'm guessing this is rolled, when it's painted it's sort of rolled, and it was rolled at a slight angle. So there's a slight misalignment there between the 2 levels of printing. Okay, but that might be just this sample. Other fake ones might not have that. The only other thing which is probably less easy for the counterfeiters to achieve is that the flutes on the original, they have a slightly sharper edge to them here. This corner is sharper. On the fake, it's a softer corner. Okay, the radius of the corner is bigger. But certainly the average DIYer, and probably even a Toyota technician, to be honest, might not be able to tell the difference. And how they actually made this thing for 70 pence or $1, you know, and packaged it and everything is absolutely astonishing. Anyway, I bought 2 of these, and so what I did is I cut the other one open because I wanted to see whether this thing would actually damage your engine. So this is a fake filter that's cut open, okay? And actually what I found is it's not a bad filter. We've got the anti-drain back rubber flap in there, looks properly made. We've got the filter element, and I've measured that, and it's about the same as an original one. There's probably a few less flutes in the paper. Obviously what I don't know is the performance of the filter paper. So I think I can say this certainly wouldn't immediately wreck your engine. I wouldn't recommend using a fake filter, but it's not going to immediately cause your engine to self-destruct. It'll probably work okay. My advice is, if you're going to buy a Toyota filter, oil filter for your Toyota, either buy it from a dealer, you can be reasonably sure it's genuine, or if you want to save a bit of money, go for a good aftermarket brand, Hengst, MAN, Bosch, one of the others, okay? But avoid Toyota filters or Toyota branded filters sold via what I would call secondary or sort of grey market channels, because there's a good chance you'll get one of these fakes. And obviously the profitability on this could be considerable. I mean, if this is selling for 70 pence, you know, if you're buying these in at 70 pence and you can sell them for £9 or £10, then that's going to be very profitable. So yeah, be careful. Anyway, thanks for watching. I hope you find that useful and informative.